Welcome to American Building. I'm your host, Atif Kader. Join me as we explore the skylines and strip malls, the crosswalks and rail crossings, the balconies, the buildings, and the boroughs shaping the next generation of real estate. Let's build common ground. Today, our guests are architect Joseph Chase, who's a principal at Skidmore, Owings & Merrill, and engineer Maxwell Hatfield Biondo of Jarvis Bowman Bowles. The project we're discussing is the Walt Disney Company's New York City headquarters, which is called the Robert A. Iger Building at 7 Hudson Square. It is a full block, 19-story, roughly 1.2 million square foot vertical campus that brings Disney's news, production, streaming, and corporate teams together in Manhattan. This building is notable not just for its program, including studios, double height production volumes, and a large central great room, but because SOM-JB&B and the team delivered it as an all electric, high performance building with on site solar, high efficiency air systems, heat pumps, and other elements that we'll be talking about through the course of the interview. The project also responds directly to New York City's local law 97, which we'll also dive into. So thank you so much for joining us, Joe and Max.
Great to be here. Happy to be here.
Amazing. So first, for Joe, you've run complex, highly technical projects at scale at SOM. So before we dive into the Disney headquarters, tell us about the projects that you've worked on before and how you think they've prepared you to take on this massive project.
Yeah. So, my career at SOM has really been focused around New York City and really large scale mixed use in New York City. So, I've had the opportunity and the benefit to work on some of the bigger projects made over the last 15 years here in New York. One of the projects that I really worked on for a long time was the Manhattan West development on the far west side. Max here also worked on that project. I think the other sort of big project for many years that I worked on was 35 Hudson Yards, residential project, also on the far west side. And then, we're going to talk about Disney today. And I think the Disney project is really sort of, following the west side downtown with another large scale building. And I would say each of those projects over the course of time have shown consistent changes as the city has changed and as technology changed and how the city approaches the requirements around energy.
So similarly, Max, you are responsible for mechanical and other systems work on incredibly demanding projects like this one. So tell us about your start as a engineer in this industry and the type of projects that you've worked on at JBB before starting on the Disney headquarters.
Sure. Yeah. So actually, similar background to Joe in terms of some of the market sectors that I've had a chance to work on throughout my career. A lot of commercial development, some higher ed, and so a lot of infrastructure upgrades. And I think that combination of market sectors really, and it's also sort of how JB&B as a company is structured, in that we give all of our employees an opportunity to work through all market sectors. And I think that gives you a real great chance to sort of mine innovation from each of those market sectors and kind of take all those lessons to whatever it is you happen to be working on. But additionally, as a company, we have a proven track record and a long-standing reputation for delivering quality design, progressive design in a cutting-edge marketplace, and but also learning our licks a bit from some events in the past. Superstorm Sandy had a major impact to New York City, and thinking about ways that we redesign resiliency into our systems. But generally, I think we've really embraced here at JB&B an approach of progressive design ideas, but with a pragmatic approach that are able to be built, and the folks who are going to operate these facilities are going to be able to do so comfortably. So I think that really lended itself nicely to a perfect teaming with Joe's team on this project.
So tell us a little bit about some of the projects you've worked on together as well. with both JBB and SOM together?
Yeah, I mean, we work with JB&B a lot. I think, and our relationship with JB&B goes back a long time. JB&B worked on Chase Manhattan Plaza, the Gordon Bunshaft
Mhm.
building in Lower Manhattan. So SOM and JB&B has a long history of collaboration on projects. I think within recent history, we work with JB&B at Manhattan West, as I mentioned earlier, which resulted in a great collaboration across multiple buildings on that sort of super block. We worked with JB&B at 35 Hudson Yards.
Mhm.
Again, that's another project where, again, the JB&B team was innovative with a super tall residential, but also mixed use projects. And then Galaxy, we work with JB&B from the beginning to really develop the systems that represent some of these changes associated with local law 97.
Yeah.
I could talk your ear off a million projects because we work with JB&B so much. So it's a long collaboration for many years that we've contributed with
That
them.
makes a lot of sense.
And to add to that too, across other cities as well. So Joe, before mine and yours time, right? A lot of collaboration in Chicago on Sears, now Willis Tower, right? At SOM's headquarters. So there's been a long-standing relationship between our offices together.
Yeah, and just to mention Chase Manhattan is right behind me.
Yeah.
Well placed for folks that are viewing this episode as opposed to just listening. That makes a ton of sense because SOM and JBB are part of the OG crew of design firms that do buildings
That's right.
again and again and again. For example, like Lyra is another really great one, Robert Silman on the engineering side.
Mhm.
So that makes a ton of sense. Okay, so the Disney headquarters project. So Mickey and Minnie come up to you and they have a design brief of what they're looking for on their new project. So more seriously, tell us about the how the project came to be, who got the first call, and what like the initial thought process was. Because when I think of Disney, I think of Florida and California, um, and streaming. I don't think of New York City, but Disney actually has a long history in New York. So tell us about some of that, the origin stuff as the project was getting started.
Yeah, I mean, Disney has a very long history in New York City. It dates to the beginning of their company. I think a lot of their operations around ABC, around ESPN, because Disney's a big umbrella for multiple companies, right? It's not just the Disney that you know from the movies. It's Marvel, it's ESPN, it's ABC. All of these entities are under that umbrella, and really the motivation for the Disney headquarters was really to consolidate those entities, and to sort of position them as a media company for the future. And a lot of what you see just in general, the Hudson Square district that the building is located is really becoming a center for media, tech, and a lot of the sort of creative class or the creative industry moving to. Google is just down the street, and there's plans for even more development around tech and media in that neighborhood.
Yeah, and I think I'll add too. I remember Joe during early project kickoff and concept, right when we were sort of surveying and walking through and interviewing facilities operators of the existing facility that the campus that they previously housed on the Upper West Side. They knew that they were going to set out to create this new headquarters and house all of those umbrella companies into one state of the art facility. And every individual we spoke to was really kind of chomping at the bit to improve the system and where their home was going to be. You kind of had the tour walking through these facilities. It was kind of multiple buildings on a super block, very disjointed, right?
Hmm.
And they were really making do with what they had available to them. And just like the energy from the beginning of this was so great with how they couldn't wait to get going. And because they've been cramming a lot of different unique programs, which we're going to talk more about, into facilities that were outdated. So everyone was excited to get going.
So talk a bit more about that existing footprint within the city of New York, because you mentioned it was disjointed. It wasn't connected with the needs of Disney as a company as it currently is, which is an amalgam of many other companies. So what were they working with currently before they started visioning something new?
Yeah, they were up on the Upper West Side, and they had a block um, that was a full block. A lot of the broadcast within that building was associated with the ABC broadcast component of their business. They had other broadcast components in Times Square and other parts of the city. Um, with a lot of the broadcast work, a lot of this is built around the life cycle of equipment, right? You have to upgrade equipment at a certain point in time, and you've got budgets around upgrading that equipment, right? So there's a sort of life cycle aspect to just that technology. And for Disney, I think all of this sort of came together at the same time. So looking for a new location to both sort of meet the next technology around broadcast, consolidate some of these other divisions all within a single building, and then also just positioning it within a neighborhood and a part of New York City where there is sort of energy and excitement around, uh, the kind of staff that Disney was trying to recruit, the type of sort of creative class employee that they wanted to attract to their facility and to their organization. All of that sort of like came together to help influence
Mhm.
them, uh, consolidate into this location and to try to get everybody located in this, let's call it hive of activity for, everybody to come together.
Yeah, I think that's a little anecdote to add to that. I think I remember during some of the early interviews or, site walks that, actually the facility that much of the broadcast set, when ABC News would kind of build a set for, say, election coverage, was actually a building that used to be an old horse stable from, but I don't know what year, but I mean, their facilities team was really doing an amazing job turning the existing facilities into what we kind of knew as, what they were able to deliver for broadcast facilities. So I couldn't believe it when I heard it, but boy, have they gotten an upgrade here with the new building.
And for folks that may be aware of just a few of the companies that Disney owns, it's an incredible array from Marvel to Pixar to Lucasfilm to ABC, to ABC, as Joe mentioned, to 21st Century Fox to ESPN, and I believe there's a recent Hulu acquisition as well. So a lot going on in terms of recording and staffing needs. So what you're describing makes a ton of sense. The site itself at 7 Hudson Yards, what was existing there before, and what was some of the challenges that that site entailed from a design and then later on a construction perspective?
Yeah, I mean, I think the site it was at Hudson Square, which I think it
Did
was
I say Hudson
largely
Yards? Oh,
did, but
okay.
that's
Let
okay.
me just say that again then. So I feel like it's stuck in my head.
It's easy to
Okay,
switch, right?
so
Um,
the site itself, which is in Hudson Square, is a challenging urban site. So talk to us about um, the the particularities of the site itself that helped to inform what you ended up designing and building later.
Yeah, the site Hudson Square. For those that don't know, is a newly created neighborhood. It's sort of west of Soho, so it's adjacent to Soho. It has all the streets of Soho, like Spring. It's sort of everything west of Varick Street, and the neighborhood, I think, has a fairly contemporary special zoning district associated with it. And in the rezoning of the neighborhood or the special district that was applied to that area, this particular site, as part of the discussions of the rezoning, was like one of the lots earmarked for bigger
Hmm.
development, right? So as part of the city's strategy around zoning, this was one of the sites that was seen as really an opportunity to do something new. With any of the kind of special district requirements, they're grounded within the kind of context of the existing buildings. that neighborhood traditionally was like the printers neighborhood within New York City. That's where all the big printing facilities are. So from mass and zoning and bulk requirements, the the footprints allowed within that district, result in really big floor plans,
Okay.
right? So like that's how these printing facilities, traditional, in the neighborhood in its traditional times, operated. Big floor plates for all the printing equipment, storage of paper, et cetera. So it's a really great neighborhood because of that historical context and how that context influenced the zoning requirements to result in really big footprints. And when you talk of any media or tech client, they're looking for big footprints. They're looking for something bigger than your typical office tenant. So the site that Disney selected really allows for these really large 80,000 square foot floor plates, which allow for high density, allows for big studio spaces, allow for news functionality, and that big floor plate is really what drives even companies like Google, who are just down the
Sure.
street with again, massive floor plates that neighborhood allows within the zoning. The one caveat is that the floor plates are big, but it's not like Midtown where you can have a super tall building,
Hmm.
right? So it's really more of like a horizontal building instead of a vertical building. So even though the building is, 1.2 million gross square feet, it's all within these really comprised of these really big floor plates that, yield that number.
When you talk about the other projects that were around there, for example, the Google headquarters, what were some of the others that you took as precedent or as um, inspiration as you were getting started in the design process for this project?
So I think when it comes to the existing precedents, when we started the Disney project, Google had not been built at that time, and the zoning text was fairly new, right? So really, a lot of our discussions around precedent were really molded around what the underlying lying zoning required in terms of the floor plate size, the bulk, and how that related to the context, right? To try to be a good neighbor with how the building sits on the street. A lot of the discussion was really about how do we fit the large density of people within the building, right? With these limits on height really comes with like a constraint with trying to get all of this, zoning area in the
Hmm.
limit, right? Which, was a real task to try to get all the, let's call it the clay of a project under the height and setback requirements.
Reboot. Yep.
Um, and then, of course, in addition to kind of trying to be a good neighbor and trying to have a building that responds to the context, we of course looked at precedents outside of New York City, precedents from around the world. Projects like Bloomberg in London. We looked at projects like in on the West Coast. Not all of those are applicable to like a New York environment when you talk about density, code, building systems. So all of this sort of gets presented holistically, and you try to take the pieces from all of these other projects and synthesize them into an approach that fits within the local context. And that's really, I would say that kind of idea about
Hmm.
locality really influenced the project. We were trying to stand out by fitting in. That was a term we used a lot on the project, which influenced everything from the selection of the green terracotta to, decisions around facade expression and, the building's organization.
So both in terms of that fitting in by standing out, as well as that local context. Local Law 97 played a very large process in the design of the building in terms of what is inside the building and serving the interior environments as well as what's outside the building as well. So talk to me about um, Local Law 97, what it entails for building owners and building occupants, and then what were some of the points that you started with as you were going down the process of an all electric building?
Yeah, why don't you do that one, Max? Why don't you kick that one off?
Sure,
Because it is
sure.
the kind of engineering-driven item.
Yeah, of course. So we knew at the onset of the project that the timing that we were going to be delivering this project, the local law 97 was going to apply to
Mhm.
us, and our project team was going to need to work through what this meant and determine how, with multiple driving missions from our client, right, set them uh, ahead of their peer in terms of sustainability, resiliency, comply with this law that was still very in its infancy, right, still being written. We were still learning how the terms of the reporting periods were actually going to, how the fines were really going to be structured, and all along deliver, a resilient, progressive, energy efficient design. The beauty of what Local Law 97 was going to do, in the spirit of what Joe was just talking about, by standing out, by fitting in, is that Local Law 97 is a carbon reduction effort, right? And so, by way of us endeavoring to create an all electric building, we are by nature improving emissions from at the building
Mhm.
level for the neighborhood. So for the occupants of the building and our neighbors, right? There is no adverse building emissions from the burning of fossil fuels or products of combustion, just inherently in this design. So that was kind of like a great, uh, kill two birds with one stone right off the bat, right? And that was going to really kind of like kick us on the right foot with fitting into our neighbors. Um, I like to kind of talk about the approach to compliance with Local Law 97. Like I said, right, is a carbon reduction strategy, and what that really means for us as the designers is to figure out a way to electrify these building systems. And electrification, decarbonization sometimes are used, synonymously. But what it really means is that in our climate zone here in the Northeast of the United States, um, we have all four
Mhm.
seasons, right? And we have hot and humid summers, and we have cold winters. And the existing technologies out there today, commercially available for what building operators are familiar with, um, you know, the thinking used to be kind of separate systems for your heating season than they are separate systems for your cooling season. And heating season used to be burning of a fossil fuel with a gas fire boiler, or we have an opportunity here in New York City in that we have a local utility that provides district steam to
Mhm.
us. So a lot of the buildings and the existing building stock in New York um, have Con Ed steam that was available actually to some of the existing buildings on the site of the project. Um, but we knew from the get go that we did not want to utilize those systems. We wanted to jump right to full electrification. And knowing the program that was going to be brought into the building, as Joe outlined, right, all these subsidiary companies, but those are very different program types. We have commercial office space, executive office space. We have broadcast news facility. We have live audience broadcast facility. There's data center, right? So there's many program types on site that had a very unique load profile for the building. So right off the get go, we thought that there was going to be a great opportunity to electrify this building's design. And the mantra we like to follow to start out with this approach is reduce, recover, then electrify. And to explain what I mean by that is, you can't just jump to straight electrification by putting in uh, certain pieces of equipment and do things business as usual. That is not a sustainable approach to this. Um, the systematic way we went through, how to get here in a comfortable way for all parties involved and all stakeholders, was starting off with reduce. And what I mean by reduce is, think about these program types that are coming into the building. And sometimes in New York City here, driven by certain market sector or sort of marketability for spaces, we over design. I'll say it. I'm an engineer. We over design things oftentimes, right? So
And by over design, you mean
let's
provide more equipment or more capacity than is actually likely going to be
yeah,
necessary.
exactly. We provide more hardware to accommodate a hypothetical load that may not actually be manifest, but the occupants and the end user get a sense of comfort knowing that they have a lot of oomph behind them at the machine room level that can drive them through these what if
Mhm.
scenarios. But it's very over designed, and at the advent of energy modeling and now metering of existing facilities of a lot of our current projects with owners who will share that data with us, we have the ability to right size those predictive loads. So we can interview our end users, understand these program types, and instead of put the kind of old fashioned high internal heat gain load densities in as the input to our load calculations, we can get that more appropriately sized from the get-go. And when we can reduce those loads, they become easier to achieve with all electric means. And I think that was a really interesting journey we set out with early on, where Disney, very sophisticated institution, and there was a lot of great trended data from their existing facilities that we were able to look at their actual utility bills and their usage on various sites to determine what is the right number we should assume for how much heat is produced in these spaces. And it was a collaborative design across their whole facilities team and all the designers, and it really helped us get to the right inputs, which was like step one of the whole conversation. After kind of reducing your loads, and rethinking that what is it do I need in order to achieve my space use type, we move on to the next word, which is recover. And that's where I get to have a lot of fun. And we start to specify mechanical systems that another nerdy mantra, which I'll give you, is don't let a BTU escape the building. And so what I mean by that is heating is precious. Heating energy is precious in this facility because the more difficult aspect of building electrification is the winter time and the heating season. That's what is the most unique for those of us who are getting who are new to building electrification. And so the old-fashioned way to design mechanical systems was in the cooling systems, pull heat out of a space and they reject them to the out of doors. Heating systems, generate heat by burning a fossil fuel. Well, why are we going to waste any heat? Why let any of that heat escape? Let's retain that heat, and we can do that through a couple ways, with some complicated mechanical systems, but through the fluids that move through the building, with water side systems and air side systems. We really through the kitchen sink at the hardware that we installed in the building to recover all that heat as much as humanly possible. And the final step was electrify. So those loads that were left over after we reduced the initial loads, we recovered heat that was already there and reutilized it in a different way. The remaining load that we had to heat was much easier and much more palatable to electrify. And that got us across the finish line with this design approach.
So essentially, it's not a one-to-one of this is the way we're going to do the building. This is the way we would have done it, and then we're just going to electrify everything. It's actually thinking through how do you optimize the needs before you actually size the equipment for the
Exactly.
electrification.
It's imperative. Yeah, exactly correct.
Yeah, and I think that's a lot of that's tied to what that data acquisition really has to do about right sizing, right? The one thing I would say, what the point is, and I think that Max was making about oversizing equipment isn't out of some like idea that we just need to put a lot of equipment in a building,
Yeah.
right?
Right.
Yeah, the idea is we oversize it because we don't know,
Yeah.
right? We want a building that's future proof, that doesn't suddenly not have what's necessary for a project, right? So this process of right sizing is really built around getting to a level of efficiency. And you can imagine in New York City where, real estate, is under constant pressure, right? The cost per square foot of a piece of real estate in New York City is so high, right?
Mhm.
Like every square inch associated with mechanical, is an impact on the economic viability of a building,
The
right?
leasable
So
square
like,
footage.
that's absolutely right. And I think like when you talk about electrification, it comes with really, it's a focus on real estate. It's a focus on what is the net area of this building compared to the gross area of this building, right? If I put another piece of equipment on a mechanical floor, that's maybe 3 less desks that I can have for an individual that are part of my workforce, right? So, part of this process of electrification in New York City has to do with reestablishing what are the benchmarks that we're designing buildings around, right? What is the amount of clay that we need to design a building, and getting to the bottom of the amount of that, so that we're building the right amount of area necessary to get the job done.
Right. And to that point, Joe, too, you were talking previously about our zoning limitations on the site, right? So the shape of the building is unique in that Joe was explaining, right? It's just kind of a building on its side, which would make you think that there is a lot of roof area, but that's not actually the case. There's the building attributes provide a really beautiful set of amenities with an open skylight in the center of kind of two towers that rise up through, and the roof space available on the tops of the two shorter towers were very valuable real estate for the mechanical systems in the building. And Joe and I got to play, a great balancing act between delivering on, the beautiful aesthetic that it
Hmm.
is and making sure it could house all of that mechanical equipment that needed to achieve this electric design. Because one major component of the all electric design are air source heat pumps, which is a piece of equipment that utilizes the ambient air as a source or sink. And that equipment needs to sit outside and breathe a lot of air. Um, and so making sure that we were able to place enough of these on our building's roof and conceal them in such a way that, they kind of didn't subtract away from the aesthetic, was a unique challenge for us with the zoning limitations on site, but it came together beautifully.
So the equipment that you described, those are part of the entire package of equipment that's
Mhm.
necessary in order to electrify a building from a mechanical, electrical, and plumbing perspective, which I think is super fascinating to understand the pieces that go into the end result of actually making it an electric building. Tell us about the other main tools or equipment that were necessary in order to execute on that goal.
Yeah, sure. So actually, to answer that question, I'm gonna kind of explain how one big charge we had from our client was that the infrastructure for this building's plant really needs to look and feel familiar to what their operations team are used to. And so this was not able to be a complete reinvention of how one thinks about the heating and cooling systems for a
Because
building.
somebody actually
It
has to
needed to be
maintain it.
familiar. Someone we have to hand over the keys for this facility at the end of the day, and those folks need to be comfortable and know how to manage this building through all the variable seasons and all the variable events within the building that come through. So actually, when we knew that we were going to be approaching an all electric design, and the team knew that we were going to be using some technologies that were somewhat new to the marketplace to kind of counterbalance that level of discomfort, we needed to do everything possible to make sure the rest of the systems in place were as familiar as possible. So a moment ago, when I was kind of describing heat recovery
Mhm.
systems, a very traditional way that we make it, a central chiller plant and facilities like this is a water cooled refrigeration plant. So we have cooling towers on the roof and big refrigeration machines and a machine room for the facility that makes chilled water. That chilled water is what gets sent throughout the facility for dehumidification and cooling loads at many different end devices. I like to think and explain to people air conditioning really should be thought of as not bringing cooling to a space, but rather removing heat from a space. So when you think of it that way, all these end devices in your space move heat all the way back through the machine room and then ultimately send that heat out through the cooling tower on the roof. Like I said before, we want to recover that heat. So the central systems for this building used very traditional water cooled chillers with cooling towers, but we added a component. We added what we call condenser water source heat pumps for heat recovery. And those devices, it's the same exact technology as the water cooled chiller that makes chill water, but it's actually connected in reverse to the system. And we use that machine. Its sole purpose is to make hot water for the building. And it draws from the source of the heat that would otherwise be rejected to the cooling tower. So we keep those BTUs in the building with a traditional water cooled refrigeration machine, and we pair that in parallel with this equipment on the roof I
Mhm.
described, the air source heat pump. So essentially, there's two sources of heat for the facility. There's a water cooled source and an air cooled source. Those two in parallel at varying stages of on off are what satisfy the building's load profile. And it was really important that we help make the transition between both of those heating sources be as clear as possible to our operating staff, because otherwise these multiple sources and a building temperature control system that you can't quite follow could really become complex and get away from the operators. So that was a very fundamental aspect to our design approach.
So I totally hear you on making this as streamlined of a equipment package as possible, and also making it something that is actually maintainable by staff that may be familiar with older systems of heating and
Hmm.
cooling buildings and ventilating buildings. Um, Given that the heat loads and the cooling on buildings, or the cold in New York City has gotten more and more extreme with climate change, um, how does that play into the design of the system? Because as more extreme weather events become more common, the
Yeah.
upsizing becomes likely more and more important because those events aren't so unusual. So how is that incorporated in the sizing of what you're doing?
That's a great question, and I think the answer to it, there's a lot of levers you can pull to satisfy that requirement. Um, and what I mean by that is that there are many design approaches and technologies available to make sure that we are providing a system design that is going to be successful throughout the future and what climate change brings to us, right? Polar vortices that have extended days in a row of really cold
Mhm.
temperatures that are abnormal for our climate zone. These are a reality that we had to think about and design this building to withstand in the future. And it's the way it can be achieved is striking the right balance of installing quantity of equipment, right? The amount of hardware you have installed, making sure there's enough space to satisfy the duty, and there's a level of redundancy. So when we talk about the water cooled plant and the air cooled plant, the installed capacity of both of those together, the sum of the two exceeds the expected load of the building. So we have inherent redundancy built into the amount of hardware installed. And what's been kind of really fascinating over the first season and a half that the facility is operating under full load is that the machines have not been taxed very heavily because the design approach for the heat recovery that I was
Mhm.
describing, the building is becoming is a very cooling dominant building. The load profile in the building there's a lot of folks reporting to work every day. They're doing a lot of things in those spaces. There's a lot of heat to
Sure.
recover. So maybe some of the systems that the operating staff weren't as familiar with, um, haven't had to turn on for many hours of the year, even in the dead of winter, which has been a really great light bulb that has gone off for the whole team. So the whole staff feels very comfortable about the kit of parts that are installed in the facility. We have a lot of levers to pull to ride us through a lot of different scenarios. And the goal that we set out on to take advantage of that free heat is really proven to be, it's working swimmingly, which
Yeah.
is very cool.
Yeah, and I would jump in just to say too, this is I think a little bit where architecture also contributes to this process, right? I think that you know
Totally.
the high performance facade of the project
Absolutely.
Let's talk about that,
is
the
like
beautiful skin around the building.
yeah, I mean that's sort of like the fundamental thing about reuse, right? Like Max talks about like taking the energy that's within the building and putting it to use, right? The principal way that you go about doing that is designing a facade that has a performance level that can retain that heat. Uh,
Exactly.
sorry, there's some background noise. The the facade itself is a terracotta facade. Um, it's a unitized facade, which I think is unique in New York City. A lot of the terracotta that you see on the market is a handset product, just due to the brittle nature of terracotta. The project for Disney was under a lot of time constraints. We had to build very quickly. So a unitized approach was fundamental to being able to sort of build the project at speed that we needed to make the project work.
Explain a bit when you say
Um,
unitized, what that particularly means in terms of production
sure.
installation.
Yeah, so unitized really means that the facade is built in a
Mm.
factory, right? So like, the traditional masonry, terracotta, you can think of projects in Chicago school type projects where they are sort of handset approaches. For Disney, we needed to do something faster, something that was built in a factory, had a level of precision, but also most importantly, is had a level of performance. And with unitized facades, there is considerations around the way you detail unitized facades to get them as high of performing as rain screen handset approaches. You have to detail the joints in very specific ways with thermal breaks. You have to sort of carefully select the performance of the glass. You have to weigh the window to wall ratio, and balance the performance of the glass locations with the locations that are terracotta and opaque, right? So we you know, it's a very beautiful terracotta facade, but there's an immense amount of thinking around, let's just call it the chassis of the frame, the aluminum frames, to really detail the thermal breaks that are part of those systems, and to get the performance of this facade at a level where we could both retain and reuse the heat, but meet all the ambitions around energy performance and a lot of the local energy code requirements around facade performance. So, I mean, that was really, fundamental to why we ended up with largely a building that was, let's call it, more opaque than you typically see in New York
Gotcha.
City. It's not a Hudson Yards building, which is very glassy. It is a Hudson Square building, which is very opaque.
And for any
um,
non-New York City people, those are two completely different parts of Manhattan: Hudson Square and
yeah.
Hudson Yards.
So in the kind of full circle, like the requirements around performance really worked well with our desire to design a building that stood out by fitting in, right, and was very contextual in its approach to the design.
Totally agree. Joe's facade was instrumental in making the whole electrification be pulled off. And one also thing I will add, we were again talking about the shape of the building and the large footprint with a deep lease span. That was actually a great ratio for the load profile that the building ended up seeing, because there's not as much skin as there is compared to total area. So all this internal heat gain was able to be recovered and sent back out to the perimeter. And the high performance facade that Joe was just describing allowed us to heat this building with a very low temperature hot water. That was, that's a feature of the electrification. When we say hot water, um, I mean 100-degree Fahrenheit water is what the heating water temperature is that's distributed around to all devices, where the legacy type facilities could be upwards of 140 to 180 degrees. So that was another kind of one of the big things with the operating staff. That's like kind of the biggest shock value when it comes to the electrified design, but it is imperative, and it is only achievable when the facade is as high performing as it was specified by SOM.
And that ties right into what you had talked about earlier in terms of the approach of reduce, recover, and then electrify. So in this instance,
Yeah,
similarly, not
exactly.
just the internal systems, the MEP, the external as well, thinking through that process as well, is
100%.
super fascinating. And I want to make sure I heard what you had said a little bit earlier, Max. Make sure I heard that correctly. Is the idea is when you are designing systems for an all electric building, incorporating the actual uses of what are happening on the inside is a critical part. So in this case, where there's going to be production equipment that gives off an insane amount of heat in certain short bursts, the ability to be able to utilize that at the times when they're used means that the most extreme events may not necessarily be as extreme as one would imagine,
You
because
nailed
the
it.
two are mixed together.
Exactly
Okay.
correct. Yeah, exactly. And what's kind of like a reverse way you want to think about it is that when we are sizing our systems and calculating those loads, you of course want to take credit for that heat that's available to you. But the way you want to be conservative and not overdo it, right, is it's kind of a nuance to the special sauce with all this, is that if you overestimate those internal heat gains and you overestimate how much heat can be recovered, you could in fact, perhaps get into a little bit of trouble with having not as much, remaining infrastructure available to carry you through. So it's a balance, right? And that's why we build an energy model. We model it so we can check the sensitivity of these. If the internal heat gains are such and I can recover it, what does the rest of my size system need to be? If we're humming along at full capacity, those systems look smaller, but you pick the right number in between, right? You don't. It's a great point that you picked up on it. It's important to, and we were fully transparent with our client group on, open books with the calculations and what that all meant to make sure that folks were comfortable with what event could take place and what does that mean.
So, we talked about Local Law 97, and that is one of the main design guidelines that was necessary to consider as you're going through the design process. Disney has its own corporate sustainability requirements. Tell us about that and how those influenced the building design itself.
Yeah, so I think, Disney, really wanted to, as part of the process, I should say, of determining the sustainability approach. Disney has, global standards that we started as a base with the process. And again, these standards span across all of their holdings around the world. So, and we do this with every client. We develop, let's call it a reinterpretation of those to the local conditions, right? And I think we knew we had to sort of build up a sustainability strategy and a certification strategy. I think in our case, based off of what this building was, how it operated, we zeroed in on the LEED
Hmm.
Platinum certification, which we successfully acquired for the project within the last year. So we are a LEED Platinum building. And the LEED Platinum approach really framed a lot of the conversations, outside of these code drivers, right? So, like, we talked a lot about Local Law 97. That's really driven by the local New York market. But there's lots of other items built around sustainability, right? From water use to things that are intangible and design related, like access to green
Hmm.
spaces and access to transit systems. And with any design process, they're built around standards, right? Like we look at whether it's code standards or program briefs or any of the number of like industry wide benchmarks that are published. And for this project, I think Disney, SOM-JB&B, A10, who was our environmental consultant. I think we molded the decision making around the framework of the LEED Platinum certification. And one of the benefits of like the New York market with all this Local Law 97 requirements is we're already way above on the energy use categories within the LEED
Hmm.
Platinum certifications, or we're already there by meeting code to push us at a level of certification that in other jurisdictions people have to work really hard to get to. In New York, we're going to see a sea change of many, many platinum buildings just because
Hmm.
the local laws require um, so much of these energy performance requirements that we're already in the ballpark of getting these higher level certifications that, 10 years ago, there was less of an appetite because they cost more money
Hmm.
and they were more difficult to achieve.
Right. Right.
And now I'm guessing because there has been a body of work already done in terms of buildings that are increasingly high performance, and then within that subset, electrification, that the process of doing so has gotten smarter and smarter and more efficient as well. That allows for an increased number of buildings that comply with these rules. So that makes a ton of sense. Um, I want to dive into some of the other key technical aspects of the building. So we talked about recording studios being a key element of the building. So they or the equipment produce a lot of heat, but also those environments have a necessity for sound control. So tell me from the architectural perspective, from the engineering perspective, how you were able to achieve the acoustic requirements. And I know you worked with the team at Cerami and Associates, so tell us about that process as well.
Yeah, I mean the acoustical requirements were big on the
Hmm.
site. There was quite a few underlying constraints. We are right next to the one train, the red line in Manhattan, right? So we've got MTA east on the east property line of the site. So the train comes by, every 5 minutes, right? Every 5-10 minutes. So the sound associated with the trains and the vibration, maybe more importantly, was a big concern for Disney, right? Because they've had previous assets in the past where they had to kind of correct for train noise, correct for transit noise. So we really needed to find a strategy where we could isolate the acoustics for the building, knowing that we were directly adjacent to the train line. So we worked with Cerami to come up with a very specific approach where basically we used a sound isolation pad and coated the entire cellar with this material, right? This is basically, it's a kind of neoprene-like spongy material that really deadens the sound of the train as it passes. This material, basically just like insulation or waterproofing that you put on any foundation, really covers the entire foundation like a bathtub. And what's unique about this particular product is that it has, structural capacity. So you can put it under the building too, right? You can put it under the foundations. So this process of sort of fine tuning the acoustical material allowed us to really spread the material around evenly and get the noise criteria at the level necessary for broadcast, right? So that was kind of step one with the acoustical process. Step two is what we call box and box construction, right? So like you put studios within a room within the larger structure of the room, right? So like you literally depress a floor slab and then set a floor on springs, right? So the floor sits on springs, and then the walls for those studios are then supported by the floor that's supported by springs. And then you put a ceiling within that box that's also isolated by springs. So from an architectural perspective, between the use of a sound isolation mat and this what we call box and box
Hmm.
construction, you basically create a soundproof environment where the external environment does not come into the space. And then in addition to those architectural elements, there's a whole cadre of mechanical strategies that Max can talk about related to insulating ducts and sort of modulating the equipment that's selected. Um, so I'll let him talk about that.
All right. And Joe, just to add to your point too, also flanking us to the south, right, is the entrance to the Holland Tunnel. So
Oh,
there's
right. Yeah.
vehicular traffic outside of the foundation wall too. So a lot of acoustical or vibration constraints outside of the site. And Joe teed it up nicely for, I guess the mechanical systems a little bit addressing a little bit closer to the source of where the end user is inside the
Hmm.
space, inside those broadcast studios, and working very closely with the architecture team and the acoustics team, traditional methods for making sure that those NC criteria are maintained in the spaces really results in furring out of walls, using lagging material or sound absorption material, and really what it means on the air conditioning side is much larger ductwork than would normally be used to serve the space to slow the air down to very low velocities. And that's a major space
So
implication.
lower
So
velocity
besides all
means
the
less noisy.
that's
Right.
correct. Yeah. So slowing the air inside the duct down is what helps reduce uh, breakout noise and radiated noise into the space. And that, as you can imagine, in a below grade area where the broadcast and live audience studios are, space starts to get used up pretty quickly. And so that was a major challenge with making sure the ductwork can be as large as required to maintain these criteria and, coordinate through the architectural ceiling and the structural beams and columns and deliver the air to the space.
Yeah, and we're talking primarily about the below grade, right? Because of like the trains and so that's where the majority of the production studios are
Okay.
located. But there is quite a few above grade too, right? And
Hmm.
the site is, as Max noted, next to the Holland Tunnel entry. And if anybody who is from New York knows that Varick is like a traffic jam, right? So there's blazing horns on Varick every day at around 3 o'clock. People heading back to
Sirens and whatnot. Yeah.
yeah. So, as part, the city also had sort of put an E
Mhm.
designation on the site, which is basically a noise constraint. So, in the selection of our glass and this whole conversation about facade performance, we're also in a place where we need to, design a facade where it performed acoustically, right? So we built 9 acoustical mock-ups as part of the projects, in the facade design, and tested those facade mock-ups with an ASTM-based test that showed how well they would perform at an STC level or an OITC level. And all of that testing, really resulted in the fine-tuned detailing of the system,
Sure.
right, that the curtain wall manufacturer provided. And that advanced testing, led to, glass makeups that improved the sound of on the floor, right? Like on the typical office floor, which also had sort of broadcast elements on those floors. So,
Mhm.
between, below grade where we had the concern for the
Hmm.
train, and then above grade, we had the concern for the Holland Tunnel and Varick Street, acoustics really drove so much of the design and the performance of the building.
And I'll add one more, Joe, right? We have the building is fully backed up on emergency power by way of a generator. And the generators happen to be located on the top of one of the towers, and immediately below the generators are some of the executive office floors. So, sort of to our own doing, we introduced sound and vibration to the site, but mitigated it with a really elaborate architectural and structural solution of a floating slab to mitigate sound going from top down into the uppermost office floors. So we really had it from all directions.
I am noting a number of similarities between the requirements in terms of um, temperature control and also sound control with
Mhm.
data centers. So the past couple of weeks, I've
Yeah.
been learning a ton about data centers, and in the not too distant future, we'll have some guests on the podcast to talk about data centers and how they're transforming the built environment in this country. But what you're um, laying out as the challenges and your solutions have corollaries within this other use case as well, which I found interesting.
Yeah, definitely.
So let's take this big picture. So the idea of moving from a gas-based, fossil fuel-based heating system, cooling system is one that probably is unfamiliar and it scares building owners and building developers, where our industry is often built on certainty and reliability and predictability, as opposed to innovation and change. So could you talk about the key aspects of electrification that may go unnoticed or may be like the selling points that you would give to someone that is a client that's reluctant to move away from a traditional MEP system?
Yeah, yeah, I can start with that because I think a lot of the benefits are
Mhm.
architectural. And I think, I mentioned earlier about building efficiencies, right? Like at the end of the day, buildings are measured in, rentable area, like how a building performs in terms of its
Yep.
efficiency, right? So when a client or a tenant thinks about like how much real estate they need to hold, every inch counts towards their performa. Like it's related to how many people they can fit in a building,
Totally.
right? So these systems are much more efficient at the level of the planning, right? So you can imagine, when I started as an architect in New York City, we all the buildings we designed had a local fan room on the floor. You had like a DX system. It sat on every floor. That then sort of conditioned air, and that hot or cold air was in a massive duct
Hmm.
that ran around the floor and provided the heating and cooling, right? It was simple system, but it took resulted in a big core,
Hmm.
took up a lot of space on the floor. These new systems that we're talking about sort of shift where the mechanical equipment is located, right? It's no longer on the floor in a room. It's on a mechanical floor. It's localized to the roof. It's localized to spaces that don't impact the planning. And all the equipment is in the ceiling now. It's not in like a space on the floor. So, what we've been starting to do, and we're working with a JB&B and Max on projects that are more in a developer contexts, in a context where you may not know the end
Hmm.
user, where we're using these same strategies within that context, within that developer context. And we're showing that these buildings are just more efficient, right? And we are arguing and showing that the loss factor. This is like a real estate metric that measures
Sure.
efficiency for determining area should go up. Like that, really, a building, a landowner who has these systems has a more efficient building, and therefore has more area dedicated to the tenant that they can actually use, right? So what you see is that efficiency that's gained from the decision to do this equipment really yields more area and makes for a better, more flexible product for the tenants, right? So like, that's directly equated to,
Hmm.
money, right? That's independent of, the fact that in New York City you have to pay a fine with local law 97. This is applicable to any city
Mhm.
in the country when you're talking about trying to have an efficient building. So like, one of the major selling points when you talk about these systems is like you just get more space back. You just get more space to put um, stuff that people want to use. Program.
That's probably the most cogent pitch that I've heard for electrification. So that on its own is such a beautiful nugget. So thank you for sharing that. Um, As the cynical developer, though, what I would say is the benefits that you described are over the operations of the building, and the presumption that I would have would be the costs associated with it are upfront. So tell me about the cost premiums, say 5 years ago, 3 years ago, now, and what you see going forward for someone that is making that choice to electrification. Is there actually an upfront premium, or are they neutral, or even potentially maybe even savings down the road?
I could take
That's
a
for
shot at
Darren
this
or
one, Joe.
Max, if you got a sense on
Yeah,
this one.
yeah. So I think it's a very important question, and I think I'll start out by saying that here in New York City, Local Law 97 is a law, and it's in place, and we're approaching the we're at the first reporting period now, and this is a reality for all of us. And there's kind of two mindsets that any building owner in New York City could approach this with. You could kind of moan and groan and say, "Oh my gosh, this is unfair. How can we fight this? Can I be exempt? I can't accommodate this at the moment." Or you could jump in and see it as an opportunity to improve your asset.
Mhm.
And that's exactly what Joe just helped describe. And there are so many amazing opportunities, low hanging fruit. We're here talking about a brand new building out of the ground construction where we had an opportunity to kind of set the stage for exactly what we want to do from the beginning. But this law applies to the entire stock of existing buildings in New York City too. But there are so many lower hanging fruit energy conservation measures that can help you incrementally move towards beneficial electrification that aren't as huge as ripping off the band-aid of saying reskin your whole building
Totally.
or kick out all of your tenants and do something because you have to change out your perimeter heating solution. Joe and I are super excited to partner with anybody who's looking for the thought process on those little incremental steps. And depending on kind of what your kit of parts are that you're approaching this, there could be capital costs. If you're comparing an existing building retrofit versus the new building, there's so many variations on how you kind of answer the question on capex and life cycle payout. But the reality is that the law is designed and written such that if you do nothing, if you elect to do nothing, the penalties increase exponentially at the later reporting periods, and it is designed to make it so that nobody does nothing because the fines greatly outweigh any life cycle cost analysis within a reasonable reporting period,
Mhm.
especially at the 2050 reporting period, that doing nothing is really not an option here. So the payout is always worth it to get going now.
Yeah, and I would add to that too. They, even outside of the context of New York, right? There's many ways to approach these systems, right? Like it's not necessarily like the same system for every application, right? And like to Max's point, there's a lot of values related to the life cycle, how you plan to operate it. I think even just like how much are you going to build into like your first cost versus what you're going to pay for as part of a tenant TI, right? Like a lot
Mhm.
of the developers have TIs
Mhm.
where, you really, a lot of this, we're talking about shifting costs from, into TI buckets and instead of
Exactly.
the,
Yeah.
the base bucket,
Yep.
right? So
Mhm.
at the end of the day, how you balance all those levers, that's a complex equation. Based on what a client needs, I mean, we can even look at strategies that are, less elaborate than what, Disney did,
Mhm.
that still achieve these results, but maybe come with other ways to think about how to plan the floor plate, right? Like we're doing a project right now in Midtown. It's a sort of a spec developer office building where we're trying to do all electric off of a localized VRF
Mhm.
system, right? Which basically just puts VRF like in a behind a louver on every floor, right? Like this is like a more bare bones way to do this.
Mhm.
That's tied to very specific size limitations and floor plate sizes, and there's other things about the constraints around the coolants that are used in those systems.
Mhm.
So there's ways to like work through it other ways, but really it's just about like balancing really a lot of those interests based on what the client needs and how they plan to operate the building.
And for anyone that may not know what VRF is, could you just briefly explain what that is?
Max, do you want to do the VR? Is
Sure.
that I'm playing the
The
engineer again.
which is what gets me in trouble all the time.
You're good at it. You're good at it. VRF is variable refrigerant flow. So it's another commercially available means for heating and cooling that essentially uses the kind of the same Carnot refrigeration cycle, but it's basically a very split refrigeration system where you get to take advantage of a piece of device that's rejecting heat, to the out of doors in one location, and then refrigerant piping is piped between the two components that ultimately provide the cooling or heating to the space.
Okay.
And it's a cost effective way to minimize, it minimizes ductwork. It's a great for retrofit solution because you can the refrigerant piping is much smaller than a duct emanating out from a central location. So it's often an approach used in the residential marketplace and some of the other smaller commercial areas. So it's got its benefits in unique ways, and it's a good approach for the project Joe is describing.
Yeah, it's tied to scale, right? Like a lot of this stuff, like any building, right, is like you got to balance the scale of the building and what's the right system for that size of a building, right? You always got to say is this system right sized for this particular client,
Exactly.
this particular approach.
So energy efficiency, electrification in general, then from what we learned is it's a continuum of strategies where it's not like I'm doing it and I'm not doing it. And
Exactly.
local law 97 in particular applies to buildings that are 25,000 square feet and over. A significant amount of the million or so buildings in the city of New York are under 25,000 square feet, so they wouldn't be subject to the fines that you're describing. So those
Mhm.
owners would likely have the ability to wait and do that monetary calculus as opposed to having to also consider in increasing fines when deciding what to do or how to improve their buildings. Do you have any tips, or you mentioned like low hanging fruits for, say, owners that fall below that local law 97 threshold to get quick wins in terms of energy efficiency?
Yeah, I think maybe the first one right off the bat, right, is envelope, tightening your envelope, right? Where the energy usage is always, where energy is escaping is through, window seals and
Hmm.
doors and what have you, right? So any way you can button up and insulate and tighten your envelope, that's right off the bat. We hear a lot in the residential marketplace. This below 25,000 is a lot of multifamily here in New York City, some smaller buildings, but heat pumps is something we hear a lot about in the residential marketplace, and there are many of them on the marketplace. A lot of manufacturers. The refrigerants being used have low global warming, right? So in terms of like everyone's stewardship to kind of what the general mission is of reducing carbon emissions, there's plenty of solutions in that smaller building scale, that between envelope, window sealing, and coming off a fossil fuel gas, if you have an oil furnace
Mhm.
or a natural gas furnace and converting to a heat pump, it's all over the place in the residential marketplace.
Yeah, I would also add too, the city is doing a lot to encourage. It's not just trying to provide penalties. Even for us, let's call it small developers doing smaller work, there is incentives now built into the zoning code that allow you to deduct, 5% of your floor area if you choose to upgrade your existing building into electrification, right? So they've also just sort of provided incentives for people who take this on, right? If you are someone less than 25,000 square feet and you are currently not electrified, you could go
Hmm.
electrified and you can build 5% more area, right? So that's another potential tenant you can get on a building, on a penthouse or something, right? Or
Mhm.
a unit in the back, right? Like there's ways that this is also incentivizing sort of smaller developers, smaller people in the
For sure.
city to be able to help add square footage, and we are talking largely about residential buildings, right? So like that helps add more residential units to a city that's desperately in need of, residential housing.
That's a great.
Right, right. As Joe mentioned, there's so many incentive programs that are opening on a rolling basis with a lot of money to be given out that either can cover the soft costs of consulting fees to kind of help with the design approach, or even the acquisition of the equipment that you're going to install and do some of the work. Um, NYSERDA has a lot of programs. There's constantly something out there, and managing the landscape of what's available. There's plenty of monies available to help guide developers to begin taking these approaches.
Those are really great points for building owners and developers of all scales. So, for folks that are listening, that are developers, that are owners, that want to explore the process of electrification for existing buildings or newer buildings that they're working on, what would be the best way for them to get in touch with you guys?
Well, I think just reach out. I mean, I think all Max and I both have a presence on
100%.
the internet,
Sure.
right? Like I think
Yeah.
you can go to SOM.com and sort of get our contact information there. I mean, I think between SOM and JB&B, we do a lot of just feasibility studies for developers who don't know what they want to do, right? Like where we would just sit down and help them program a strategy that they may choose or not choose to execute, right? So I think those kind of services, I think we offer those kind of let's call them consultancy services that don't necessarily need to be part of a
Sure.
project.
Mhm.
So I think just reach out and we can talk about a game plan to try to get the city more electrified. Because we're dedicated, at SOM to try to push this forward. I mean, I think we've got a strong ethical drive to make these things happen beyond just the meeting of the code requirements, right? So like we're very much interested in trying to uh, get the city electrified.
I will completely echo what Joe said, and I think our firms are culturally aligned with that approach, and we feel the same way. Reach out, navigating the landscape of those incentive monies that are available. We have some in-house expertise for that. So all the above, exactly what Joe said. Completely agree.
Amazing. So, thank you so much for your time today, Joe and Max. Really appreciate learning about the Disney headquarters and the process of electrification. So, thank you again.
Yeah, great conversation.
Yeah, thank you for having us. This was a blast.
Thank you. I'm Atif Kader, and thanks for joining me on American Building. If you enjoyed this episode, be sure to subscribe on your favorite listening app and leave a rating and review. America's housing crisis is one of our greatest challenges, but what are the real solutions? Hear from the developers and other industry experts driving meaningful change. Get our exclusive guide, Housing in America: 8 Ways We Can Solve Our Way Out of a Crisis, at AmericanBuildingPodcast.com.